Hello everyone, welcome to Sanskrit Tutorials. In my previous video, I have discussed about the midpoint theorem. So in this video, I will discuss the circle chapter. Completely all the theorems, statements I will discuss and I will explain this, those meaning of the statements, and we will just have the notation and the theorem statements. So in this video, I am going to discuss about the circles. In the circles chapter, there are total 11 theorems based on different aspects like the chords and the angles subtended at the center and regarding the cyclic quadrilateral. So like this, there are 11 theorems. In that, one by one, we will discuss the theorem statements. The first theorem states that theorem 9.1 states that equal chords of a circle subtend equal angles at the center. Equal angles at the center. Equal chords of a circle subtend the equal angles at the center. What is the meaning of this statement? If you see, for suppose we consider this as a circle and this is the center of the circle O. Here we have two chords. For suppose that is AB, we have one chord, and we have PQ, the another chord. Given that AB is equals to PQ, that means AB is equals to PQ. The both chords are equal means the angles subtended by these chords. That is angle AOB is equals to angle POQ. This is the statement of the first theorem actually. That means if the chords are equal, then the two angles subtended by those chords at the center are equal. This is the statement of the first theorem. Okay, then we will have the second theorem statement. Theorem number 9.2, that is if the angles subtended at the center of the circle are equal. If the angles subtended at the center are equal, then the chords are equal in length. So here students, this is the converse of the theorem 9.1. ಇಲ್ಲೇನು 9.1 theorem ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ರು ನಮಗೆ ಈಕ್ವಲ್ ಕಾರ್ಡ್ಸ್. ಹೌದಾ, ಒಂದು ಸರ್ಕಲ್ ಇಂದ ಈಕ್ವಲ್ ಕಾರ್ಡ್ಸ್ ಏನದಾವಲ್ಲ, ಈಗ ಫಾರ್ ಸಪೋಸ್ ನಾವು ಇಲ್ಲಿ ಏನ್ ತಗೊಂಡಿವಿ, ಎ ಬಿ ಮತ್ತೆ ಪಿ ಕ್ಯೂ ಈಕ್ವಲ್ ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎ ಬಿ ಮತ್ತೆ ಪಿ ಕ್ಯೂ ಅನ್ನೋದು ಈಕ್ವಲ್ ಆದ್ರೆ ಇಲ್ಲಿ ಎರಡು ಆಂಗಲ್ ಏನ್ ಸಬ್ಟೆಂಡ್ ಆಗಿದೆಯಲ್ಲ ಸೆಂಟರ್ ಅಲ್ಲಿ, ಎ ಓ ಬಿ ಮತ್ತೆ ಪಿ ಓ ಕ್ಯೂ ಅವೆರಡು ಈಕ್ವಲ್ ಬರ್ತಾವು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಥಿಯರಮ್ 9.1 ಅಲ್ಲಿ. ಆದ್ರೆ 9.2 ದ ರಿವರ್ಸ್ ಕೇಸ್ ಯಾವ್ದ್ರದ್ದು, ಥಿಯರಮ್ 9.1 ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ, ಫಾರ್ ಸಪೋಸ್ ದೇರ್ ಇಸ್ ಅ ಸರ್ಕಲ್, ಅಗೇನ್ this is the center. For suppose we have two angles like this, okay, two angles like this, that is let the angles be, this the center be O, L O M, and it is also X O Y. For suppose like this. So what they are telling, if these angles are made by two chords like this, okay, and if the angles are equal, here ಇಲ್ಲಿ angles equal ಅದಾವ, L O M is equals to angle X O Y ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಸೆಂಟರ್ ಒಳಗೆ ಬರ್ತಕ್ಕಂಥ angles equal ಇದ್ವು ಅಂತಂದ್ರೆ ಈ ಕಾರ್ಡ್ಸ್ ಲೆಂತ್ ಒಳಗಡೆ ಈಕ್ವಲ್ ಇರ್ತವೆ. ದಿಸ್ ಇಂಪ್ಲೈಸ್ ಎಲ್ ಎಂ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ವೈ. ಸೊ ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ ಆಂಗಲ್ಸ್ ಏನಾದ್ರು ಈಕ್ವಲ್ ಇದ್ವು ಅಂತಂದ್ರೆ ಸೆಂಟರ್ ಒಳಗಡೆ ದ ಕಾರ್ಡ್ಸ್ ಅವ್ ಯಾವ ಕಾರ್ಡ್ಸ್ ಇಂದ ಏನು ಆಂಗಲ್ಸ್ ಸಬ್ಟೆಂಡ್ ಆಗಿರ್ತಾವಲ್ಲ ಆ ಆಂಗಲ್ಸ್ ಆ ಕಾರ್ಡ್ಸ್ ಸೇಮ್ ಲೆಂತ್ ಇರ್ತದೆ. 9.1 ಕಾರ್ಡ್ಸ್ ಈಕ್ವಲ್ ಕಾರ್ಡ್ಸ್ ಇದ್ವು ಅಂತಂದ್ರೆ ಅವು ಸೆಂಟರ್ ಹತ್ರ ಈಕ್ವಲ್ ಆಂಗಲ್ಸ್ ನ ಸಬ್ಟೆಂಡ್ ಮಾಡ್ತಾವ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಹಿಯರ್ ದೀಸ್ ಆರ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ 9.1 and 9.2. Okay, now we will have the theorem number 9.3. What is the theorem number 9.3 states means? Theorem 9.3. See, in 9.1, 9.2 we discussed about the angle subtended at the center of the circle. So now 9.3 states that the line or the perpendicular from the center of a circle, from the center of circle to the chord, center of circle to the chord bisects the chord. What do you meaning of, what is this meaning of bisecting the chord means? Again, take a circle, we have a chord and we have a center here. Okay, center O, chord AB, suppose, and here we need to draw one perpendicular draw ಮಾಡಬೇಕು. ಸೆಂಟರ್ ಇಂದ ಏನಾದ್ರೂ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ರಾ ಮಾಡ್ತಾ ಇದೀವಿ ಅಥವಾ ಈ chord ಗೆ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಬಂದಿದೆ ಅಂತಂದ್ರೆ 100% for suppose this OP is the perpendicular ಅಂದ್ರೆ this OP will bisect the chord AB. That means if OP is perpendicular to AB, then 100% AP is equals to BP. So statement ಏನ್ ಹೇಳ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಒಂದು ಸೆಂಟರ್ ಇಂದ ನಾವು ಏನಾದ್ರೂ ಒಂದು chord ಗೆ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ರಾ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ ಆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಈ chord ಅನ್ನ 2 equal parts ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ತದೆ. ಅಂದ್ರೆ AP will be equal to BP. So that is P is midpoint of AB. ಇದು theorem state ಯಾವುದು 9.3. ಇನ್ನ theorem 9.4 ನೋಡುವ. theorem 9.4 ನೋಡೋದಾದ್ರೆ again converse of 9.3 statement. ಈಗ 9.2 ಸ್ಟೇಟ್ಮೆಂಟ್ 9.1 ಇಂದ ಕನ್ವರ್ಸ್ ಆಗಿತ್ತಲ್ಲ ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಕನ್ವರ್ಸ್. ಯಾವ ರೀತಿ ಕನ್ವರ್ಸ್ ಅಂತಂದ್ರೆ a line drawn from the center of the circle, okay, center of the circle to bisect a circle, a line drawn from the center of the circle to bisect a circle is perpendicular to the chord. ಹೌದಾ? ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನ್ ಹೇಳ್ತದ ರಿವರ್ಸ್. ಇಲ್ಲಿ ಏನ್ ತಗೊಂಡಿದ್ವಿ ನಾವು, ಇಲ್ಲೇ O ಅನ್ನೋದೊಂದು ಸೆಂಟರ್, ಓಕೆ, ಸೆಂಟರ್ ಆಫ್ ದ ಸರ್ಕಲ್. ಇಲ್ಲಿ AB ಅನ್ನೋದೊಂದು ಕಾರ್ಡ್ ಇತ್ತು. ಈ O ಇಂದ ಒಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡ್ರಾ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ ಬೈಸೆಕ್ಟ್ ಮಾಡ್ತಾ ಇತ್ತು ಅಂತ. ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾರೆ ಅದ್ರದ್ದು ರಿವರ್ಸ್ ಕೇಸ್ ಏನ್ ಹೇಳ್ತಾರ ಅಂತಂದ್ರೆ ಫಾರ್ ಸಪೋಸ್ ಅಗೇನ್ ಇಟ್ ಇಸ್ ಅ ಸರ್ಕಲ್, ಓಕೆ, ಇಲ್ಲಿ ಒಂದು ಕಾರ್ಡ್ ಐತಿ ಅನ್ಕೊಳ್ಳೋಣ. ಸೊ ಇಲ್ಲಿ ಸೆಂಟರ್ ಇಂದ ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡ್ತಾ ಇದೀವಿ, ಓಕೆ. We are drawing a line which is passing through the center such that here PM, that is it bisecting the chord, is equals to MQ. ಇಲ್ಲಿ ಅದು ಆಲ್ರೆಡಿ ಬೈಸೆಕ್ಟ್ ಮಾಡಾತೈತಿ ಅಂತಂದ್ರೆ then this OM will be perpendicular to PQ. ಈ OM ಅನ್ನೋದು PQ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರುತ್ತದೆ. ಇಲ್ಲಿ 9.3 ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾರ, ಆ ಲೈನ್ ಏನಾದ್ರೂ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದ್ರೆ ಕಾರ್ಡ್ ಬೈಸೆಕ್ಟ್ ಮಾಡ್ತದ ಅಂತ ಹೇಳ್ತಾರ. 9.4 ಅಲ್ಲಿ, ಓಕೆ, ಇಫ್ ಇಟ್ ಈಸ್ ಬೈಸೆಕ್ಟಿಂಗ್ then 100% the line is perpendicular to the chord. This is the statement of 9.4. Okay, now the theorem number 9.5 we are discussing. Theorem 9.5 states that equal chords of a circle, equal chords of a circle or equal chords of a circle or of congruent circles, same circle or maybe congruent circles are equidistant equidistance from the center or from centers so ಇಲ್ಲಿ ಮೀನಿಂಗ್ ಏನಪ್ಪಾ ಓಕೆ ದ ಈಕ್ವಲ್ ಕಾರ್ಡ್ಸ್ ಆಫ್ ದ ಸರ್ಕಲ್ ಅಂದ್ರೆ ಕಾರ್ಡ್ಸ್ ಈಗ ಸರ್ಕಲ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಕಾರ್ಡ್ಸ್ ಈಕ್ವಲ್ ಇದ್ವು ಅಂತಂದ್ರೆ ಆ ಕಾರ್ಡ್ಸ್ ಸೆಂಟರ್ ಇಂದ ಸೇಮ್ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಇರ್ತಾವು ಅಂತ ಹೇಳ್ತಾರೆ. ಹೇಗೆ ಅದು ಒಂದು ಡಯಾಗ್ರಾಮ್ ತಗೊಂಡು ನೋಡೋಣ ಸರಿನಾ. ಸೊ ಇಲ್ಲಿ ಸೆಂಟರ್ O is the center of the circle. Again we are taking two chords. Okay, we are taking two chords AB and this PQ. Okay, so AB, it is given that AB is equals to PQ, given that length AB is equals to PQ. AB is equals to PQ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ ನಾವು ಸೆಂಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ತಗೊಂಡ್ವಿ ಅಂತಂದ್ರೆ let this be L and let this be M. Okay, these are the distances from the chord to the center. Then 100% if chords are equal, then they will be equal equidistance, that is then OL is equals to OM, that is they are at the same distance, equidistance from the center in the same distance ಒಳಗೆ ಇರ್ತಾವು ಅಂತ ಅರ್ಥ. ಸೊ ಇದು ಸೇಮ್ ಸರ್ಕಲ್ ಒಳಗಿತ್ತು ಅಂತಂದ್ರೆ ಆರ್ ಆಫ್ ಕಾಂಗ್ರೆಂಟ್ ಸರ್ಕಲ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಅಂದ್ರೆ ಕಾಂಗ್ರೆಂಟ್ ಸರ್ಕಲ್ಸ್ ಅಂತಂದ್ರೆ ದೇರ್ ವಿಲ್ ಬಿ ಟೂ ಸರ್ಕಲ್ಸ್ ಆಫ್ same radius. So congruent circles means the circles having the same radius and different centers. Same radius ಇರಬೇಕು ಮತ್ತೆ ಸೆಂಟರ್ ಅನ್ನೋದು ಏನಾಗಿರ್ಬೇಕು ಡಿಫರೆಂಟ್ ಇರಬೇಕು. ಅಂತ ಸರ್ಕಲ್ಸ್ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ ಕಾಂಗ್ರುಯೆಂಟ್ ಸರ್ಕಲ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಈ ಕಾಂಗ್ರುಯೆಂಟ್ ಸರ್ಕಲ್ಸ್ ಅಲ್ಲಿನೂ ಅಷ್ಟೇ ಸರಿನಾ. ದ ಸೇಮ್ ಡಯಾಗ್ರಾಮ್ ನಾನು ಯಾವ ರೀತಿ ತಗೋಬಹುದು ಅಂತಂದ್ರೆ ಸಿ ದ AB again, this is again PQ, the center is O, here the center is O dash, clear. So here the center is O dash and this is the distance between the center and the chord. Again here this is the distance between the center and the chord, again same. If AB equal to PQ, then OL equal to O dash M. ಇಲ್ಲೇ ಸೆಂಟರ್ ಡಿಫ್ರೆಂಟ್ ಇದಾವಲ್ಲ ಅದಕ್ಕೆ O dash ಅಂತ ತಗೊಂಡಿದೀವಿ. ಸೊ AB equal to PQ ಆಗಿತ್ತು ಅಂತಂದ್ರೆ OL equal to O dash M ಬರುತ್ತೆ. This is the theorem number statement of theorem number 9.5. Now we will have theorem 9.6. What is theorem 9.6 statement? Okay, here we have taken equal chords of a circle are equidistant from the center. The converse of this statement we will take, that is chords equidistant from the center, chords equidistant from the center of a circle are equal in length, chords equidistant from the circle are equal in length. The reverse statement, again the same circle, if we take the center, we take two chords we take. Okay, that is here I will take this as a L and this M and this X and Y. So again I take to here, if I been given that this O and A and the O and B are equal, if OA equal to OB, then 100% this chords will be equal, that is LM equal to XY. See here, it is been given that if the chords are equal, then the distance between the center is equal. Here, if the distance between the center is equal, then the chords are equal. So these are the statements of 9.5 and 9.6. Now we shall discuss about theorem number 9.7. So theorem 9.7. What is the meaning of theorem 9.7? Means the angle subtended at the center of circle. The angle subtended at the center of the circle is double the angle subtended at any other point on the circle. Okay, so this is the statement of the theorem number 9.7. That means here we need to take a circle. Okay, and so this is the circle, this is the center of the circle. Let there be an arc, that is a PQ. PQ is an arc. So here let us join this OP and this OQ. So there, if we join this OP and this OQ, here one angle will be formed like this, one angle will be formed like this. So this angle will be double the angle subtended at any other point by the arc. That means this here we will take PR. So here this center, whatever the angle subtended at the center will be double the angle subtended at the any other point on the circle. That means this angle POQ is equals to 2 times of angle PRQ. Here, wherever it may be. For suppose this may be like this. Okay, this PLQ we will take. Again, POQ is equals to 2 times of PLQ. Okay, so this is for not only for minor arc. It is also true for major arc also. For suppose again there is a center here O. There is a line passing through the center which is called as a diameter. AB, let us consider that AB is the diameter. AB is the diameter means again these angles are equal. So whatever the angles formed are no. So these angles will be half the angle subtended at the center, or okay, half the angle subtended at the center. That is again angle AOB is equals to 2 times of angle. Let us consider this C and this D. 2 times of angle ACD and again angle AOB is equals to 2 times of angle ADB. Okay, ADB, ACB and ADB. So this is the statement of a theorem number 9.7. Okay, students. So here what happens? The angle subtended at the center is double the angle subtended at any other point. Okay, this is the statement of the theorem 9.7. Okay, now we shall discuss the theorem number 9.7. Okay, 9.8. Theorem 9.8. Okay, what is the meaning of theorem 9.8? Means the angles subtended in the same segment are equal. Angles subtended in the same segment are equal. What is the meaning of angles subtended in the same segment? Means here we will take a circle, center O, chord AB. This chord AB will divide the circles into two equal parts. chord AB ಏನ್ ಮಾಡ್ತೈತಿ ಪೈಲೆ ಈ ಸರ್ಕಲ್ ನ ಎರಡು ಈಕ್ವಲ್ ಪಾರ್ಟ್ಸ್ ಆಗಿ ಮಾಡ್ತೈತಿ ಹೌದಾ. ಈ chord AB ಇಂದನೇ ಎರಡು ಆಂಗಲ್ ಸಪರೇಟ್ ಆಗತ್ತಾವ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. that is here one angle like this, we will take another angle like this. Let us this call as C and let us call this as B. So here angle ACB is equals to angle ADB. ಯಾಕಂದ್ರೆ ಎರಡು ಒಂದೇ ಸೆಗ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇದಾವೆ. ಸೊ ಎರಡು ಒಂದೇ ಸೆಗ್ಮೆಂಟ್ ಅಲ್ಲಿ ಇದ್ವು ಅಂತಂದ್ರೆ ಅವು ಈಕ್ವಲ್ ಇರ್ತಾವಂತ. ಥಿಯರಮ್ 9.8 ಏನ್ ಹೇಳ್ತಪ್ಪ ಅಂತಂದ್ರೆ the angles subtended in the same segment are always equal. Okay. Theorem 9.10 states that if a line segment joining two points subtends equal angles at the two other points lying on the same side of the line containing the line, then the four lines points are lie on a circle. That means there is a circle with the center O, chord PQ, two. Okay, if a line segment subtends equal angle, okay, at the two other points, let this as R and this as S. Here the line segment, this line segment PQ is subtending two equal angles at the same side of that line, then this all four points lie on the circle. ಇಲ್ಲೇನು ಸೇಮ್ ಸೈಡ್ ಈಗ ಒಂದು PQ ಅನ್ನೋದು ಒಂದು ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ಅದ. ಈ ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ಎರಡು ಆಂಗಲ್ ನ ಸಪರೇಟ್ ಮಾಡ್ತೈತಿ ಸರ್ಕಲ್ ಮೇಲೆ ಸೇಮ್ ಸೈಡ್. ಸೊ ಈ ಎರಡು ಈಕ್ವಲ್ ಆಂಗಲ್ ಏನಾದ್ರು ಸಪರೇಟ್ ಮಾಡ್ತಾ ಇತ್ತು ಅಂತಂದ್ರೆ ಈಕ್ವಲ್ ಆಂಗಲ್ ಏನಾದ್ರು ಸಬ್ಟೆಂಡ್ ಮಾಡ್ತಾ ಇತ್ತು ಅಂತಂದ್ರೆ ದಿಸ್ ಪಿ ಆರ್ ಕ್ಯೂ ಅಂಡ್ ಪಿ ಎಸ್ ಕ್ಯೂ ಈಕ್ವಲ್ ದವು ಅಂತಂದ್ಮೇಲೆ ದಿಸ್ ಆಲ್ ಫೋರ್ ಪಾಯಿಂಟ್ಸ್ ಲೈ ಆನ್ ದ ಸರ್ಕಲ್. ದಟ್ ಈಸ್ this is a concyclic. So we call this as this P Q R ಮತ್ತೆ S lie on the circle. That is they are the concyclic. They are concyclic. Students, till now we have discussed about theorems 9.1 to 9.9. In this chapter we have remained with the two theorems, so that I will explain now. Before that theorem, going to that theorem statement, you all need to know about a concept that is cyclic quadrilateral. And this the properties of cyclic quadrilateral are must and should be we should know for the next two theorem statements. That is, a cyclic quadrilateral means a quadrilateral whose all four vertices lies on the circle. For suppose these are the four vertices, that is A, B, C, D. Here ABCD is a quadrilateral. Which is the all four vertices lies on a circle. Such a quadrilateral is called as a cyclic quadrilateral. ಯಾವ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಇನ್ನು ನಾಲ್ಕು ವರ್ಟೈಸಸ್ ಹೌದಾ, ಒಂದು ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಇನ್ನು ನಾಲ್ಕು ವರ್ಟೈಸಸ್ ಏನಾದರೂ ಒಂದು ಸರ್ಕಲ್ ಮೇಲೆ ಇದ್ವು ಅಂತಂದ್ರೆ ಆ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ನ ನಾವು ಸೈಕ್ಲಿಕ್ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಅಂತಂದು ಕರಿತೀವಿ. ಸರಿನಾ? ಇಲ್ಲಿ ಅಪೋಸಿಟ್ ಆಂಗಲ್ಸ್ ಆಫ್ ಅ ಸೈಕ್ಲಿಕ್ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಆರ್ 180 ಏನಿರ್ತವೆ ಸೈಕ್ಲಿಕ್ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಹೌದಾ. ಸೊ ಇದನ್ನ ಸೈಕ್ಲಿಕ್ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಅಂತಂದು ಹೇಳ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಸೈಕ್ಲಿಕ್ ಕ್ವಾಡ್ರಿಲ್ಯಾಟರಲ್ ಅಂತಂದ್ರೆ ಏನು ಅಂತಂದ್ರೆ a quadrilateral whose all four vertices lie on a circle is called as a cyclic quadrilateral. So with the definition of a cyclic quadrilateral, we now have another two theorems. That is theorem number 9.10. Theorem 9.10. So theorem 9.10 states means the sum of either pair opposite angles of a cyclic quadrilateral. Okay, cyclic quadrilateral is 180 degree. Okay, so cyclic quadrilateral means that is the opposite angles, either pair, both the opposite angles, both pair of opposite angles will be 180, that is the supplementary. That means if there is a circle, okay, if there is a quadrilateral like this, that is PQRS, PQRS, this is the center of the circle, then see, as I already told you, the cyclic quadrilateral means whose all four vertices are must be on the circle, right? Here they are on the circle. So what is point here means the angle PQR is equal to, okay, sorry, plus angle PSR is equals to 180 degree, is equals to 180 degree. Opposite angles, another opposite pair of opposite angles are QPS, angle QPS plus angle, okay, QPS angle QRS must be 180 degree. So this is the, okay, this is the statement of the theorem 9.10. What is theorem 9.10 means? The statement states that the sum of the either pair of the opposite angles of a cyclic quadrilateral is 180 degree or the supplementary. That means if it is a cyclic quadrilateral, then the sum of the opposite angles, these two angles must be 180 and these two angles must be 180 degree. This is the statement of theorem number 9.10. Now we will discuss the theorem number 9.11, which is the last theorem of this chapter. 9.11. See, as we seen from starting the theorems, all the theorem statements, one is theorem, the other one is the converse of the above, second theorem the converse of the above, like that only we have seen. So in this the converse is, see here we have taken it is a cyclic quadrilateral, then we are telling the opposite angles are 180 degree. If in a quadrilateral, if the opposite angles of a quadrilateral, are 180, then the quadrilateral is cyclic. That means the same equation or the same quadrilateral, if we consider means, here I'll take ABCD, see, this is the center. Here I took, it is a cyclic, and I have to show, if it is cyclic, then the sum of opposite angles will be equal. Here, if the sum of opposite angles of a quadrilateral are equal, 180 degree, then 100% that quadrilateral is a cyclic quadrilateral, that all the four vertices will be on the circle. So this is the statement, that is if angle DAB plus angle DCB is equals to 180 degree, also the other one it is 180 degree, then angle ABC plus angle ADC is equals to 180 degree, then ABCD is a cyclic quadrilateral. So this is the statement of 9.11. See, 9.10 it represents that, 9.10 says that if the quadrilateral is cyclic, then the opposite angles are supplementary, that is 180. Then theorem 9.11 tells that if the opposite angles are equal, then the quadrilateral is cyclic. So this is the statement of 9.11. So these are the theorems which are important that in the circle chapter. All the theorems I have discussed clearly. So proofs I will discuss in my next video.